In this video, we're going to look at finding the area of a triangle using the formula 1/2 AB sine C. So far in your studies, you will have found the area of triangles when you're given the base and a perpendicular height. So for example, you might have been given a right angle triangle. We found the area by multiplying the base by the height and dividing by 2. Or we might say that the area is 1/2 base times height. The formula 1/2 AB sine C allows us to find the area of triangles when we don't have the perpendicular height. So for example, if we had a non-right angle triangle and we were given some of the values, we could find the area. In this video, we're going to see why the formula works. We're going to apply it to some basic examples and then finish off with some harder questions. So let's start off with 4 different triangles. We just simply want to find the area of each of these triangles. None of them are drawn accurately, but they'll give us some idea on what we're doing. So if we consider the first one, a right angle triangle, we've got now 5 and 4. All we would do is 5 times by 4 divided by 2. So we could say now that the area is going to be 1/2 multiplied by the base multiplied by the height. If we label these up, we could say that this one was going to be A and this one was going to be B. And in general, we could say now that the area was going to be 1/2 AB. So 1/2 multiplied by A multiplied by B. So in this particular example now, we could say that the area would be 1/2 multiplied by 5 multiplied by 4. Quite clearly, it doesn't matter which order you do those in. So that's going to give us now that the area is going to be 10 and the units will be centimetres squared. This one right here, we've got a base of 2 and a perpendicular height of 3. Remember, the perpendicular will be at right angles to the base. So in this one, we've got the area is going to be 1/2 multiplied by 2 multiplied by 3, which will give us now that the area will be 3, and that's going to be square feet. This one right here, we don't have a perpendicular height. We've got a slant height, and we've got now one of the shorter sides of a right angle triangle. So this is the hypotenuse, and here's the shorter side. So using Pythagoras, we could say 10 squared minus 6 squared square rooted will give us the perpendicular height. So in this particular case, we're going to have 8 meters. So we weren't given the perpendicular height, but it's fairly easy to find using Pythagoras. So the area is going to be 1/2 multiplied by 6 multiplied by 8. So the area is going to give us 24, and that will be meters squared. This one right here, base of 12, height of 6. So the area is simply going to be 1/2 multiplied by 12 multiplied by 6. So the area will be 36, and that will be millimeters squared. So we've been given in each of these, or we're able to find the perpendicular height. We've got the base, so we simply multiply the 2 and then divide them by 2. Let's now move on. Let's look at this example right here. We've got one of the sides, we've got a base, and we've got the angle size. Again, this isn't drawn accurately, so we'll simply now work with our new formula. What we want here is a perpendicular height. So if I drop a perpendicular down, what I create here is a small right angle triangle. So if I just draw in the right angle, we can see that we've got a hypotenuse of 10 and an angle of 30. This is the opposite. So if we just consider now this small triangle here, hypotenuse and opposite. If we use our trig ratios or SOHCAHTOA, we can find the opposite. The opposite is given to be the hypotenuse multiplied by the sine of the angle, and I'll call the angle theta. So if we consider this length right here, this length is going to be 10 sine of 30 degrees. So in a calculator, the sine of 30 degrees is one of our special angles. Just checking we're in degrees mode, shift mode 3. The sine of 30 degrees will give us a half. So this particular one is going to give us 1/2. If we multiply that by 10, we're going to get 5. So the opposite, that length right here is going to be 5, and that will be millimeters. And we've got now one of our lengths here and our other length here. So all we need to do to find the area is say the following. The area is going to be 1/2 multiplied by the base, which is 17.3, multiplied by the perpendicular height, which is 10 sine of 30 degrees. So we can write out the area is 1/2 multiplied by 17.3 multiplied by 5, and just putting that in a calculator. Let's multiply this up, multiplied by 5 multiplied by 17.3, and that will give us now 43.25. So the area is going to be 43 0.25, and that will be millimetres squared. So all we've done is found now this height. So we've done 1/2 base multiplied by 10 sine of 30. Let's now look at this again. What I'm going to do here is just label this triangle up. So let's say that this is going to be side, let's go for this one as side A. Let's therefore say this is going to be angle A. We'll say that this is going to be side B, this will be angle B. We'll say this side is C, this is going to be angle C. What we're going to do is look at finding the area of this triangle in terms of A, B and C. So let's go ahead and drop my perpendicular down. So there's my perpendicular. So we've got now the right angle that this is making with the base. So what we want is the base. So we can now write that the area of this triangle, so the area is going to be 1/2 multiplied by the base, which is A, multiplied now by the perpendicular height. Now the perpendicular height, if we consider what this is right here, this is the opposite. The perpendicular height is the opposite, and the opposite is going to be B multiplied by sine of C. So all we're doing to get this height is this length multiplied by the sine of the angle. So what we can now write is multiplied by B sine of C. So, tidying this up a little, we can write that this is going to be 1/2 AB sine C, and that gives us now the area of our triangle. So just consider that this height is B sine C. Before it was 10 sine 30. So all we're doing now is simply using these letters to write out our formula for the area of a triangle when we don't have the perpendicular height. So we got 1/2 base times by height. So we can generalise. This is our formula. Area is 1/2 AB sine C, where C is either the included angle, as you might hear it being called, or the enclosed angle. We multiply 1/2 by A, by B, and by C, or sine C, I should say. And that will give us the area of this triangle. So let's look at an example. We want to find the area of this triangle. So the dimensions are similar to what we looked at before, but what we don't have is a perpendicular height. So let's go ahead and get one. So what I'm going to do here is just extend the base. Here's the base. I'm now going to drop a perpendicular down from this point right here. So what we've got then is the perpendicular. And I've created a larger right angle triangle. So if I put the right angle here, we want this length right here. This is going to be the opposite, okay? So our opposite is just here. This is the hypotenuse, this is the angle. So we can say that the opposite here, so opposite, is going to be equal to 10 sine of 30 degrees. So opposite, hypotenuse multiplied by the sine of the angle. So our area is going to be 1/2 multiplied by the base. The base is 5. That is the base. The base doesn't continue here. It's just this part right here. So we can have 1/2 times by 5 times by 10 sine of 30 degrees. In the last question, we saw sine of 30 was a half. 10 times half is a 5. Or 10 times 1/2 is 5. So let's multiply this up. And that's going to give me now 25 over 2, so the area will be 12.5, and that will be centimetres squared. So there's our area. So we've done 1/2 base times by the height, or 1/2 AB sine of C, and that is our enclosed angle. Now that's one way of looking at it. Let's have the triangle back again. I find looking at this slightly less intuitive, but you might prefer to drop a perpendicular just here. So what I'm going to do is drop the perpendicular here. So this time we're going to have our right angle there. So I can see that the hypotenuse here is going to be 5, and we can find the opposite. That opposite is going to be 5 sine of 30 degrees. So the opposite is 5 sine of 30 degrees. This time our base is 10. So all we've got now is a base of 10 and a perpendicular height. So we can say that the area is going to be 1/2 multiplied by the base, multiplied by the perpendicular height, which is going to be 5 sine of 30 degrees. And again, that's simply going to give us now 12.5, and that will be centimetres squared. Exactly the same. I prefer viewing it like so, but it's alternative for you to look at it like this. Okay, So we've got 4 examples here. None of them are drawn accurately. They're just rough sketches and all of the angles are in degrees. So let's go ahead and find the area of A. So what we can say then is the area is going to be 1/2 multiplied by the base, which is going to be 10.4, multiplied by the perpendicular height, which is going to be 12 sine 30. So we can put multiply by 12 sine of 30 degrees. So the area is going to be 1/2 multiplied by 10.4 multiplied. 12 sine of 30 is going to give me 6. So we're going to get the area is going to be 3 lots of 10.4, which is going to give me 31.2, and that will be meters squared. You can, of course, put this straight into a calculator. So what we would have had is 0.5 times by 10.4 times by 12, and you might even want to put multiplication in here. You can do, it really doesn't matter, the sine of 30 degrees. And that will give us our value of 31.2. So 31.2 meters squared. Okay, let's look at the next one. This time we've got now that the area is going to be 1/2 multiplied by 9.2 multiplied by 6 sine of 40 degrees. So if you wanted to label these up, this is 1/2 AB sine C. So A, B, C. In this one, A, B, C. So if we just put this through a calculator, we can get our value. So let's grab that up and we'll just work out this one. So 0.5 times by 9.2 times by 6 times by the sine of 40. As stated, you don't need a multiplication sign there. And that's going to give us now, what do we have? 17.7. So the area is going to be equal to 17.7, and that will be meters squared. So nice and straightforward, we plug it in and show this. So if you're doing an exam question, this would be absolutely fine. You don't have to simplify in the majority of them. Do check though with your exam. Okay, on this one, if we consider what we could do here, we could say that this one is going to be A, this one is going to be B, and this one is going to be C. So we do 1/2 AB sine C. We could have gone the other way. We could have said, for example, that this one is A, this one is B, and this one is C. You could have even gone the other way and just now taken the enclosed angle. So let's grab that one up and said that this one was going to be A, this one was going to be B, and this one is going to be C. And you will see that they will all come out, assuming these are rounded correctly, to the same value. Okay, on this one, we've got now 6 kilometres, 8.1 kilometres, we've got 60 and 40. What we're after is this angle right here. So if this is 60 and 40, that gives me 100, that's going to give me 80. So all we need to do from here is say that the area is going to be, now area will be 1/2, and at this time I'm going to write it in brackets. We could write it as 1/2, then we're going to have 8.1, and then we're going to have 6, and then we're going to have the sine of 80 degrees, and we would simply plug that into the calculator and get our answer. So let's do that then. Let's do 0.5, and again you can use brackets or multiplication, times by 8.1 times by 6, and then times by the sine of 80 degrees. So let's put that in, sine of 80 degrees, and that will now give us 23.9. So what's that going to be? So let's write that into 1 decimal place, 23.9, and that will be kilometres squared, or square kilometres. So nice and straightforward. All we're doing is labelling these up and putting the values in. Okay, let's move on and look at some others. Okay, in this particular example, in E, we've got now the angle X, we've got one side, and then we've got this side right here, and we're told that the area is 180 centimetres squared. So if we consider now that the area is given to be 1/2 AB sine C, we can work this backwards. So if we wanted to label these up, certainly don't have to. This could be A, this will be C, this will be B. So what we could say is the following, and I'm going to use now some brackets here. We could say that the area is going to be equal to 1/2, and that's going to be now A, which is 57.5, multiplied by B, which is going to be 17.5, multiplied now by the sine of X. So we're trying to find X. Now we know that the area is 180. So we can write in 180 is equal to 1/2 multiplied by 57.5 multiplied by 17.5 multiplied by the sine of the angle. So what I'm looking to do here is make sine x the subject. So I could say 180 divided by 1/2 multiplied by 57.5 multiplied by 17.5 will be equal to sine x. You can, of course, simplify this. If you've got a quicker way of doing it, feel free to do it. If you want to simplify this part right here, go ahead. So what we would say now is x will be equal to the inverse sine. We're finding the angle, so we're taking the inverse. On the calculator, that's shift sine. So what we're going to have then, 180 over 1/2 multiplied by 57.5 multiplied by 17.5, or whatever value you've simplified this to give. So again, check it in degrees mode, shift mode 3. So what we're going to do is the inverse sine, so shift sine, and then we're going to simply feed this value in right here. So we're going to have 180 over now 0.5, and again, if you want to use brackets you can do, or multiplication. We've got 57.5 multiplied now by 17.5, and then we'll just close our brackets off and we'll get the size of the angle, 20.96. So we'll round this to 1 decimal place and say the value of x is going to be now 21.0 degrees. So all we've done is simply work that backwards. Okay, let's have a look at another one. This one here, we've got 3 meters, 2 meters, we've got 2x, we've got x, and we've got 114. The sum of these two must be equal to the exterior one. So what we can now do is find the value of this angle right here. So what we can say then is 2x plus x, which is going to give me 3x, will be equal to 114. So if we divide both sides by 3, that's going to give me 38. So we can say that this angle right here is going to be 2 lots of that, which is 76 degrees. So the area is going to be 1/2, and then we're going to multiply this now by either one of these. So we can say multiply by 2, multiply by 3 sine of 76. And again, entirely up to you on how you want to do that. Those will cancel, so this is simply going to be in the calculator 3 sine of 76 degrees. So let's go ahead and do that. So now we've got 3 sine of 76 degrees. And that gives us now 2.91. So we'll do that to 1 decimal place, and we'll say that that's going to be now 2.9, and that will be meters squared. So there's our area. So we've had to use a bit of algebra, but it's fairly straightforward. Okay, this one here, with this one you can use a few different things. You could go ahead and use Pythagoras if you wanted. I'm just looking at this now, and this is an isosceles triangle. So we can say that this is going to be 52.3. So we can find the area. We can say that the area is going to be 1/2 multiplied by this length multiplied by this length multiplied by a sine of 45. So we could even say 52.3 squared times by the sine of 45. So let's see what that gives us in a calculator. So 0.5 times by, and you could have 52.3 squared, or if you like, if you're not confident with that, 52.3, and then times that by the sine of 45 degrees, and that will give us that the area is going to be 967, and we'll just do that now to 1 decimal place. So we're going to have 967, and let's just round that up. So that's going to be 0.1, and that's going to be centimeters squared. It's more likely that you'll do that to 3 significant figures as 967 centimeters squared. So it depends on the level of accuracy or the rounding that they ask in the exam, but anything along those lines would be perfectly fine. So there we go, finding the area of a triangle when we don't have the perpendicular height using 1/2 AB sine C. The majority of questions that you'll get in exams can be of this form. Some might be more functional. If you do get one of those, simply draw a triangle, put all your information on, and go from there.